Today we discuss the question related to the resistance of the vehicle. So let us start 10 question related to the previous chapter we studied before. So question number 1 is, what is running resistance of the vehicle? So options are rolling resistance, aerodynamics resistance, sum of rolling resistance and aerodynamics resistance. Option D, traction force. So we know the running resistance is sum of rolling resistance and aerodynamic resistance. So option C is correct answer. The explanation of this question 1 is, F running resistance is F rolling resistance plus F aerodynamics resistance. So F rolling resistance formula is mu mass of the vehicle into G, acceleration due to gravity. Mu is the property related to friction, which is called coefficient of friction, and the formula for F aerodynamics is 0.5 into rho into C drag coefficient into area of the frontal area into V square. So it is the resistance that will affect when the vehicle is running. So running resistance is directly proportional to mass of vehicle, frontal area and velocity. So increasing any of the parameter will increase running resistance. Tractive force is the effort from powertrain. Rolling resistance is the frictional resistance that will have to overcome. Aerodynamic resistance is the drag force against the motion of the vehicle. So the question in the above question, running resistance of the vehicle is rolling resistance plus aerodynamic resistance. So option C is correct answer. Next question number 2. Suppose the road gradient is G is 10%, then what is the corresponding angle approximately value in radian? So we have to find the corresponding angle. We know the road gradient G is 10%, which is equal to 0.1, and the formula for road gradient is G is equal to tan alpha. For small angle, tan alpha is equal to alpha. So from G value, G is equal to 0.1 is equal to alpha. So the angle is 0.1 in radian. So option B will be correct answer. Next question. Question number 3. If the vehicle mass is 800 kg, what is the gradient force approximately value in Newton caused by road gradient is 10%. So value G is equal to 10%, which is equal to 0.1, and given mass is 800 kg, then we have to find the gradient force. So F gradient is equal to, we know, mass of vehicle into G into sin alpha. As g, from g we know tan alpha, alpha is small, so alpha is equal to 0.1, and sin alpha is also small, so sin alpha value is equal to alpha, which is equal to 0.1, and g value is equal to 9.8. Let us approximate is equal to 10, and mass of vehicle given 800. So multiplying 800 into 10 into 0.1, which is approximately 800 Newton. So answer will be D. Option D will be correct answer. Next, question number 4. What will happen if the traction force is negative? So we know traction force is the effort from the powertrain. That means what force will need for the vehicle to be just that. So the options are vehicle will accelerate, vehicle will decelerate, vehicle will first accelerate and then decelerate. Option D will be vehicle will run at constant speed. So question asked, if traction force is negative, we know net force is equal to F traction force minus F rolling force minus F aerodynamic force. So if traction force is negative, then the total will be negative. So F net will be negative. That means F net is equal to mass into acceleration of the vehicle will be negative. That means vehicle will be not accelerate, that will be decelerate. So option B will be correct answer. Next, question number 5. Suppose the vehicle is running at constant speed. Given data, vehicle is moving at constant speed, velocity, that means constant, at flat road, while with rolling resistance 100 Newton and aerodynamic resistance is 100 Newton. Then what will be the traction force required? Velocity is constant, that means acceleration equal to 0. We know F net, F traction force minus F rolling resistance minus F aerodynamics resistance. F net equal to mass into acceleration of the vehicle is equal to F traction force, F rolling resistance given 100 Newton, and F aerodynamics resistance given 100 Newton. As acceleration is equal to 0, implies that F traction force equal to 200 Newton. So option C will be correct answer for question number 5. Next, question number 6. Which one of the curve below represent road gradient of 10% if the mass of the vehicle is 1 ton? 1 ton is equal to 1000 kg. So the question and the options are B, A, C, D, and this is the graph we have to calculate which represent the vehicle having weight 1 ton and road gradient of 10%. So question number 6, we know F gradient equal to mass of the vehicle into G into sin alpha, as alpha is small, so sin alpha will be equal to alpha. Mass of the vehicle is 1000 into G value 9.81 into alpha is 0.1. After calculating, we get 981 Newton, which is F gradient. So approximately 981 is equal to 1000. So this curve will be the right answer. So this is option A, which is big line, is correct answer. Next question number 7. What will happen if vehicle is made 50% heavier but all the parameters remain same? Options are running resistance will decrease, running resistance will increase, and option C remains same. Option D, aerodynamic resistance will increase by a factor of 1.5 squared. We know F running resistance is F rolling resistance plus F aerodynamics resistance. So rolling resistance formula is mu K, kinematic coefficient of friction, into mass of the vehicle into G, and aerodynamic resistance is 0.5 into rho, coefficient of drag, into area, frontal area of vehicle, into velocity square. As the running resistance is sum of rolling and aerodynamics resistance, so rolling resistance is directly proportional to mass of the vehicle. So if the mass of the vehicle is 50% higher, then running resistance will increase. So aerodynamic resistance is independent of the mass. As the formula, we can't find any mass related to aerodynamics formula, and we find mass only on rolling resistance. So running resistance increased if mass increased. So option A will be correct answer. Option B will be correct answer. Running resistance will increase as mass increases by 50%. So option B will be correct answer. Next question number 8. If rolling resistance is 150 and aerodynamics resistance is 400 and traction force is 600 Newton and gradient 0, then what is the net force? We know F net is equal to F traction minus F running. We know F running is sum of F rolling plus F aerodynamics, and F traction given 600 Newton and rolling given also f gradient is also. So f rolling is 150 plus aerodynamics resistance is 400 and gradient is 0. So after calculating 600 minus 550 minus 0, f net will be 50 Newton. So option B will be correct answer for question number 8. Next, question number 9. If the traction resistance is equal to total running resistance, then which of the following will happen? We know F net is equal to F traction resistance minus F running resistance. If traction resistance is equal to running resistance, then F net will be 0. So F net we know mass into acceleration. As mass can't be 0, so acceleration will be 0. When acceleration will be 0? When velocity is constant. So the vehicle will run at constant velocity. The answer will be option C for question number 9. Next, question number 10. If the vehicle is running on a road having 10% gradient, 10% means 0.1 at a constant speed, that means velocity is constant, implied acceleration will be 0. On a flat road, that means gradient force will be 0, will accelerate approximately 1 meter per second square. All the parameters remain same. We know net is equal to F traction force minus F rolling minus F aerodynamics minus F gradient. Due to constant speed, acceleration of vehicle is 0, we know, so F net will be 0 and F traction is equal to F rolling, that means F traction minus F rolling minus F aerodynamics. F gradient is 0 as flat road is given, so first take it equal to not 0, so F gradient. From this, F traction is F rolling plus F aerodynamics plus F gradient, and due to flat road, F gradient is 0, so F net is equal to F traction minus F rolling minus F aerodynamics. As all the parameters same, F traction will be same. F traction will be same. So after calculating from equation 1 and equation 2, F net is equal to mass into acceleration. Vehicle is equal to F gradient. implies that if gradient we know, mass of the vehicle into g into sin alpha, which is equal to alpha. So you are cancelling mass, acceleration vehicle is equal to g value 9.81 into alpha, which is equal to 0.1. So approximately 0.981, which is equal to 1 meters per second square. As question asked approximately, so option will be true. That's all for today, and this is the explanation of all the question from question number 1 to 10. You can watch, and I will provide the PDF in the description box, or you can comment for any explanation, and you can ask the PDF. Thank you.